Evening all. How are we doing on this sunny Wednesday? Yes, I actually got out in the garden today and did some gardening, which was a rarity. Actually left the office and touched some grass. Literally. Yeah, I'm not a fan of the heat generally, but today wasn't too bad. I was quite surprised when Claire said it was 26 degrees. It's normally the kind of weather where I cower under a fan somewhere. Thank you, Aaron. Yes, we had a wonderful weekend at Pitcon, and I think I met quite a few of you there, which was really cool. It's nice to put some faces to some names. Yeah, really cool weekend. And if anyone gets a chance to go to Pitcon in the future, because I'm sure there'll be another one, then yes, make an effort to get there, because it was a really good weekend. I was thinking before starting the stream actually, if anyone wants to see the presentation I gave, I could pop on the Pitcon stream of my bit at the end of the live stream tonight. So if anyone is up for that, shout out and I shall do it. But for now, what have I been doing? Well, let me just go zoop. I've been working on the scanning and nav tutorial. Working on these tutorials is a real sort of uphill grind. It's very slow and clunky, and I keep adding extra tooling to make the process quicker and easier, but it's still really slow. But we're getting there. I reckon we're about 80% done with it now. We're getting to the end of the medium range bit, and then the short range bit is relatively small. So that should be the end of the tutorial at that point. I've changed it so you only go to the helm once during the process. So we're losing that second having to get out of the chair, go back to the helm, press my buttons, just to kind of speed it along a bit and make it flow a little bit better. Yes, Tanasi, I fixed the bug where the Sol planets don't have textures, and I fixed the Pluto texture as well, because before I had angled Pluto so that the bit that we have no data for is on the dark side where you can't see it. But of course, now that we've got sensors that can show the whole planet on the bridge, it has a big black bit on the side. So I just used generative fill in Photoshop to fill that in, and it actually went quite well, to be honest. It doesn't look too bad at all. In fact, I'll show you exactly what it looks like. Where's my other tab? Did I close the content browser? I think I did actually. Let's open another one. Oh, that's my email. Sorry, everyone. I'll close that. Hang on. Is it? Oh yeah. Open on the other window. I've got it set up so the start bar in Windows only shows the things that are open on that screen, which is a little bit confusing sometimes. Set myself to do not disturb on Discord as well, otherwise I will get pings. So yeah, so this is 50% real data and 50% generative data from Photoshop. And if you kind of draw a bell shape like that, that's kind of where the line is. If But you can see it a little bit if we zoom in, because the real data is a little bit sharper. So we go down here a bit. You can see you got a bit of a line there where it goes from sharp to a little bit blurry, and then all that's the generated data. And what I've done is, because there's a little bit of overlap, places where we have actual craters, so this is real world crater data, I've kind of deleted that from the generated data to make sure that we retain known craters that we actually know about on Pluto. But yeah, to be honest, it's pretty seamless, and the real world data where it's incomplete, in some sections it's like literally just a few pixels worth of data and it's really blurry, but you can at least see the color. So I've made sure that the generated data has the same general coloration of the bit we have no actual proper data for. So this bit was all dark and that bit was all dark, so we've just retained that. And looking at it being equatorial, it looks like there's like a heavy band of tholins around the equator of Pluto, which is quite interesting from a science perspective. But yeah, you really can't tell, like looking at it like this, where the difference is between the real world data and the generated data. But yeah, that gives us a full map of Pluto without any black bits, so that's good. What else did I do? So on the tutorial, I've made a couple of changes to the names and the titles of some of the sensors hardware. Now, I think I've mentioned the space-time curvature mass inferencer before, which is this one, where it takes the point curvature of space-time and then uses Einstein's field equations to work out how much mass would have been needed to cause that curvature of space-time, therefore how much mass that planet must have. Nice and sciencey. But I did the same for the medium range sensors as well, so I can find it. So the medium range sensors are a multi-band interferometric spectrometer. It's a bit of a mouthful. Let me try that again. Multi-band interferometric spectrometer. Multi-band interferometric spectrometer. Let's just call it MBIS for short. But the idea there is it uses an interferometer and a spectrometer, and it combines those to look at planets, look at their spectrum, do some spectroanalysis, and work out what the chemical composition is, etc., etc., etc. But this is the fun bit of doing the tutorial, is coming up with the actual hardware for the sensors and kind of working out how they actually work. And again, trying to make it as sciencey as possible, like real world sciencey as possible. So, the hardware we're making for the ship is like plausible in the real world. So like with our space-time curvature mass inferencer, like the explanation we're giving in game is based on real science. It is based on Einstein's field equations, but it's hardware that we don't actually have in the real world, but it's plausible, so we could technically build it if we had that technology. So I like that bridge between science and sci-fi, and I'll try and adhere to that every step of the way. And I'll need to do the same thing for the short-range sensors as well. So we'll come up with a nice name for them. One other big change that I'm going to make thanks to doing the sensors tutorial. So, as part of the tutorial, I'm having to write down the individual steps, why we're doing the things we're doing, why there are 4 different sensor modes, and what is the actual practical purpose of having that sensor mode available. So we're not just arbitrarily throwing out 4 different sensor suites. We're saying, right, this is for this is for that, that there's a use case for each of these sensor arrays. And right now in the game, there's a little bit too much blur between them. So I'm going to make it as such that when you when you just look at a star system and you click View Details, I'm going to change View Detail to focus sensors, or words to that effect. Basically, you're focusing the long-range sensors at that location in space. When you first click on that, it won't show you the planets. So in order to reveal the actual planets, you'll have to do the survey. It adds that layer of discovery to exploring those star systems from afar on the long-range sensors. And then on the medium-range sensors, they won't have a passive mode, so they will just have a single one-shot survey of the system. So the idea from a UN procedure perspective is that when you arrive at a star system, the standard procedure is to run the medium range scan. So you arrive, you do the scan, that increases your general knowledge of that system, and you proceed from there. So that has a very set purpose and a set function within the process of the exploration. And obviously the short range scan tells you all the juicy stuff. Whew, a lot of words. Okay. So as I say, I'm about 80% done with this. So we are currently on step 72, 73. Yeah. So we're currently here. So we're at the point where we're waiting for a medium range survey to complete. There's probably another 5 to 10 lines of dialogue just to summarize what that looks like and why. And then we're on to the short range scan, where we discuss the planet and the planet map. And that's it done at that point. So maybe more than 80%, maybe 85 to 90%, but we're almost there with this. So that's good. That aside, there's a few bits and pieces we need to do on the ship, obviously, to clean it up. Like that needs to be made to fit, so I'll have to redo this top section. I'll probably leave the base the same and just make a slightly bigger top bit just to make it fit for now. And then let's go and have a look at the actual map a minute. Claire reminded me there was a couple of wall panels and a floor panel in engineering that need making, so we'll do that. And generally just cleaning and polishing, really. So I think, yeah, so we need to make a split panel for there and the doorway. We've done those ones, so most of this is done. Oh yeah, we need a doorway for there. Yeah, the last multiplayer stream we did actually didn't go too badly at all. There were a few issues, but nothing insurmountable. Like, most of the bugs we have now are niggly things. Alright, so as I've mentioned a few times, this particular stretch of corridor is still paining me because of how big these windows are and how stretched this is, and I'm still 50-50 on whether or not I add a bulkhead in the middle to squish these down a bit. Jury's still out on whether I do that or not. If I can't come to a firm decision by the time everything else is done, then I'll just panel it up and put it out as is. We need to do some internal panels in here just to clean this up a bit. I think that's pretty much that. We've done all the floor panels in here, and we have to do the lights for here. One of the things I realized whilst making this is that the general layout of this section, especially where it comes to the lights, is that the point of focus is at the end points of each segment. So, you know, it joins up there, and where it joins you get like a balustrade. your brace that goes across is also at the section, the join. Words. And also the lighting is all at the join as well. So we've kind of focused all of the detail in the join between segments rather than having it in the middle of a segment like it is everywhere else, which means that our snapping point for everything is in the middle of the segment, and we're going to also have to have one in between segments as well. So when we place things like the lights, we can snap them to the brace rather than try to align them to the middle there. So I'm going to have to add snapping points around there for that, and also in the straight bits as well. And then we can position those lights properly, because if we turn on, where are we? F deck, ceilings. You'll see that all of these lights are all misaligned, and their world origin is up here where the snapping point used to be. Like that one's not even in the middle for some reason. So the snap location needs to be moved down to there, and then the whole thing needs shifting across. And that's not really doable on scale without having snap points there, otherwise you're having to sort of manually fiddle each one in. And also you'd have to have a different version of the light with a different world origin for every corridor curvature, like one for that. It would get a bit messy. So by putting the snapping point between the segments, we get to just use a single mesh, and you know, the whole thing becomes a little bit easier. So that's another job that I need to do, and that sorts all the lights out. I need to add a couple more, or at least one big one there. I need to move some of the tutorial highlights that are in this corridor. It should be a 10-minute job, that shouldn't take too long. Yeah, that's about it really. I think we are like super close to being able to put this out on the demo. And then down here we have that piece to do. This is currently blocking the nav mesh, which means when you're doing the tutorial, it sends you around the houses to get to the capacitors because it can't get through here. So that needs fixing. How do I turn that layer on? I'm sure we had some wall panels there. Do I not? Did I not do that yet? We shall see. But yeah, so it's just final spit and polish now, really. Right, well, let's do this first and get that fixed, because that's kind of breaking the tutorial at the moment, which we can't have. Very specifically, Mr. Seeker, as I've alluded to before, the reason we have segmented the ship the way we have, so everything is in set segments, is so that we can manage things like air pressure. So if air pressure is managed in a segmented way, then if you had a hull breach over here somewhere, then that vacuum would spread from segment to segment, and we can then logically pass that along programmatically to spread the vacuum throughout the ship. And then we can obviously stop that at bulkheads if they're closed. So yes, so there will be processes in place to manage air pressure throughout the ship, and you'll be able to, you know, replenish the air and, you know, restore the air pressure as required. With the game in its current state and the tech in its current state, we don't have the ability to just punch massive holes in the ship. At some point in the future that might be possible, The biggest challenge with that is the NPCs. So obviously the NPCs rely on the pathing and the nav mesh, and if you go punching a massive hole in the ship, then all of a sudden the NPCs don't know where to go, where they thought they could get to, they suddenly can't, and it starts to cause a lot of challenges with managing the crew. If it was just players, it would be fine, but NPCs are another factor altogether. And then, yeah, as Claire says, well, I've been saying it for a while now. It's difficult to say when the demo update will be ready. Like I keep saying, we're taking it day by day. Every day we fix more bugs, we polish it a bit more, and every day we get closer to being able to say, yes, right, we've reached the point where we can put it live. But we're not going to put it live until we feel that it's ready. And my line in the sand is, it shouldn't be a step backwards from the current demo. So if something in the new demo is worse than the current demo, then we need to resolve that so there are no backward steps. And all of the new stuff that we've implemented needs to be, polished, bug-free, or at least bug-free as much as possible, and all working smoothly in multiplayer. We're practically there now. It's just these last little bits that we're polishing off. Thank you, Hurricane. Yes, I was, in all honesty, I was bricking it like all morning ahead of the presentation. I'm not a great public speaker, as you can probably tell, listening to me mumble my words. But yeah, it was nice. It was nice to finally get up there and share the technical side of what I've been working on, because as quite a lot of people came up to me during Pitcon and said that they had no idea that we had gone to the depth that we have with the Galaxy. And I think that's true across the board. People don't realize that we have really built a galaxy. We haven't just said that we've built a galaxy. We haven't just randomly scattered some stars in a circle. We've really built a galaxy with proper astrophysics, and it's really quite complicated behind the scenes. It's why it's taken a year to build. So yeah, it was nice to be able to do a presentation, get that across to people, to really make people aware that yes, we are simulating a full galaxy properly. Yeah, whether or not the demo can be considered early access or not, it's an ongoing debate. Technically, yes, the demo is already early access. I mean, it's out there. People can freely download it. We are updating it as regularly as we can. I mean, is that not early access when you really boil it down? For us, the term early access and actually going to early access means packaging the project up properly as a product on Steam, just doing away with the demo because it's not needed anymore, and that opens up things like DLC content, the fact we can put supporter DLCs out there, so we can put things on Steam which is back the developer, give them $10 or something, stuff like that. So going into early access on Steam just opens a few doors for us in that regard, but at the same time it's more of a line in the sand. So right now we're in pre-alpha, and some would argue we're very, very much in pre-alpha, if not pre-alpha. Early access for me is making that decision, right, we are now shifting into an alpha state, so we're no longer pre-alpha. So once we can call it alpha, then we will go to early access. That's kind of our line in the sand. Until then, we'll just remain a pre-alpha tech demo, and we'll update the demo periodically as and when new things are ready to show off. I think that's probably the most sensible way of doing it for us, with our chosen distribution model. Vibe coding. Wow. Yeah. So honestly, I've tried vibe coding, and I've tried it for mostly shader code, and every single time it's produced trash. I mean, nothing it's made has been any good. Like I wanted to make like volumetric planetary rings, for example. So I went onto ChatGPT and I used the latest model. I even did research projects, and I wanted to produce the most optimized HLSL code I possibly could to do volumetric planetary rings via ChatGPT, and it couldn't do it. Like, every bit of code that it generated crashed, and it didn't know how to do it. Like, for example, when you run HLSL code in Unreal Engine, that code is running within a function on the shader. Like the back-end shader code has a function which runs the custom node that you enter data into, as a user of Unreal Engine, which means you can't define functions within that, because then you're defining a function within a function, which you can't see because that's part of the back end. But when you're entering your custom node, it can't take functions. So of course ChatGPT is throwing functions in left, right and center, and none of it works because it doesn't understand the nuances of Unreal Engine and how that backend works. So even after I told it that, and I said, look, that's not going to work, you can't do this with functions, you need to do all of this inline within the node, it still didn't work. It confidently told me things which it was like super confident would work, and just consistently failed to work. So I'm sure vibe coding works well for, I guess, things like Python and languages which are popular and I guess well represented in the training data. When it comes to things like HLSL code and perhaps C++ and game engine specific stuff, I don't think that's as well represented with LLMs, so they're not as good at that sort of thing. That's a long-winded answer, but yeah, that's basically my experience of it so far. I like it as a concept. I think for me as a time-strapped developer, if I can put my requirements into something like ChatGPT and it say, right, here's the base code, go forth and improve it, then brilliant. I've just saved myself days to weeks of work. Ultimately, I'm still the one finishing that code off. I'm still the one implementing my ideas as to how something should work, the whole logic side of it. But at least I'm getting a leg up and getting things done quicker than I ordinarily would. And I think from that aspect, it's great. But you can't just say, right, I want a system that does X, Y, and Z, write me that system, please, and expect it to come back with a finished, polished bit of code that just works, because it won't. Yeah, I guess a couple of the things I have used ChatGPT for is troubleshooting. So I can't remember what it was now. There was something. Oh, it was the. So basically, if you have a controller plugged in, the mouse doesn't work in the menus, which we have now fixed. And I used ChatGPT to get to the bottom of that, because it didn't matter how much Googling I did and how much research I did, I could not figure out why having a controller plugged in messed up the mouse. And it turns out it's because Epic's new Common UI plugin does like some kind of funky mouse emulation in the background, where it tries to be helpful by moving the mouse to the currently active widget element. So if something's in focus, it moves its virtual mouse to the item in focus, so that when you press a controller button, it presses that button. But of course, if you're trying to move a mouse around at the same time, the two are conflicting. And I could find the answer to that nowhere. And ChatGPT figured it out for me. So I sent it off on one of those research things it can do. It trawled the web, it found things I couldn't find, and eventually told me what the problem was. It didn't fix it for me, but at least it told me what the problem was and what was causing it. So again, it saved me time and effort by saying, right, that's broken because of this. So I was like, right, okay, great, now I can fix it. Sorry, CSI. Yeah, I got carried away with that then. Yeah. So, in summary, to date, it doesn't matter what AI tool I look at, and I am a futurist. I'm interested in AI. I like the technology. I think it has a lot of potential, but it's not a replacement for a human. Like every single job I've given to AI, no matter how well prompted it is, isn't as good as if I'd done it myself or someone who's better at me than that thing has done it for me. Like, AI models might look good until you actually try and put them in a game engine, and then you work out that they're trash. AI code, at least in the industry I'm in, doesn't seem to be very good using the languages I use. And even for things like lore and story, and coming up with lore ideas and such, sometimes it just makes up nonsense. So I use AI as like a brainstorming tool. So I can chuck ideas at AI and it comes back with its responses, and that might trigger another idea, and it's good for brainstorming, prototyping, and just idea checking, or going off and looking for information for me, which saves me the time and effort of doing it myself. It's a tool, it's not a solution, at least yet. At this point in time, it's still not a replacement for anything. Yeah. And I say right now because obviously I am fully confident that give it a couple of years, and many people like Sam Altman and everyone are saying that give it a couple of years, there will not be programmers anymore. And I think that's true. I think AI will eventually replace programmers, but I think in the near term, it's programmers who use AI will replace programmers that don't. I think that's kind of the near term thing that's going to happen. So, as with any business, as with any industry, you need to stay ahead of the curve. If you don't, you fall behind. And, AI is not going anywhere, and it is going to change the world. So, we have two options really. Either we stay ahead of the curve, we stay on top of it, or we fall behind. So, I'm choosing the former. I will keep up with AI, I will stay on top of it, and I will use it responsibly. But yeah, human in the loop, that's the key. Right, anyway, that's enough ranting. Let's sort out this panel. Do we have a snap guide for it already? Yes, we do. That makes life easier. Does it have a snap point in the right place? Yes, it does. Even better. Sorry for blinding everyone. Right, so let's make sure I'm doing this in the right place. Do other versions of that? No, we don't. Okay, that should be the general template of what we want to do. I've never touched COBOL or Pascal or anything like that before. C++ is the most complicated thing I've ever used, or the most low-level thing, should I say. telling me that those faces are not coplanar, which is always fun. So the question is, why not? What about them is not coplanar? That one is. So that one's alright. What's wrong with this one? Oh, now let me do it. Weird. I won't question it. Hang on, something I forgot to do. Those should be inset. It's been a while since I did this now, so I've forgotten already how I do them. So I have an additional challenge doing this that you can't see, and that is that my central monitor of 3 is broken. So the monitor that I have as my actual work monitor that I do everything on, every like, I don't know, 5 or 6 pixels, there's a horizontal black line going across the screen, and it goes from pretty much the bottom to halfway up. So I can kind of still see what I'm doing, but not entirely. So it's just a fun added challenge to my day job. Did I create a template for that and leave it somewhere useful? That is the question. I mean, I'd like to think that I did. forgetting to move the templates into my template pile, like these ones. You can go share that lot. Yeah. What I want to do, Zephnaly, is actually just swap them around, but I've got a desk that can go up and down now, but none of the cables reach. So I've ordered some more cables off Amazon, and once those arrive, I will then fix the monitors and move them around. I do have some spares, but they're a slightly different size, and OCD compels me not to have 3 monitors that are different. Like, I can't have one that's different to the other 2. That would just be madness. Well, apparently past me didn't leave a template lying around to make my future life easier, so I shall just make another one. Thanks for nothing, past me. So I'll put a copy of that template there so I don't lose it. on Earth. Oh, I see. How close are they together? 0.1 of a centimeter. So if we merge a bunch of that together, that should fix those little problems. It's looking betterer. What's wrong with this one? Autosave and drink. Sorry, I've been ignoring the chat while I've been working on that. Screw size. I will let you know in a sec. I think it was 1.5 centimeters, if I recall. Ah, 1.732. basically 17 mil. Pitcon was amazing, thank you, Triple Helix. Yeah, really, really good. Yeah, eventually we do need to count all the bolts. I mean, it would be rude not to. Is that less than 5? Oh no, it's just within. Should be fine then. Yeah, I might need to tweak those bolt heads so they're a little bit more metric. I think the wall panel ones are a slightly different size. Hang on, let's have a look. I know they're the same, 1.7 something or other. Fortunately, they are all a shared component, so if I edit one of them, it does actually edit all of them all at once. I would need to re-export the panels, but we don't need to manually resize every bolt if we don't need to. Very amusing. The whole imperial versus metric thing is a bit of a weird one in the UK because it really kind of depends on your age. Like, I grew up with imperial because I spent a lot of time with my grandparents, and of course they're of the era where imperial was the norm. And then when we switched over to metric, obviously being old, they didn't. So I kind of grew up with imperial measurements, so I kind of still visualize things in inches. And of course we still use miles and miles per hour in the UK, even though we're metric. That's true, yeah. Stones for weight. So yeah, we're kind of a bit of both here. We should just use SI units for everything, really. Yeah, I mean, like, we're supposed to use the metric system, and we do for some things. But for a bunch of other stuff, we still use Imperial. Like, we still fill up our cars in gallons. That's even just more confusing. So what are we looking at here? So this is ring 1, floor panels. So it should be that one. I think that might actually be the other side of the wall. Okay. So key deck interior walls, move that to there. Right. Let's import our new one. You had another tab somewhere. Right, so we want box collision on that, and a bunch of materials. Okay. So that fixes the tutorial issue. So we have this corridor here is an odd one because we have a lot of panels. What I might do is equalize the size of these rooms, because the idea originally that this was the startup capacitors. But since then, I think I'm going to use this for the actual full battery backup of the ship. So it needs more room anyway. And the only point of this room here was for a workshop. So it's just a bunch of 3D printers for the most part. So we can get away with splitting that more equally down the middle, which means we can have 3 segments there, potentially a bulkhead, and then 3 segments there. So I shall give that a whirl. Yeah, let's do that. Which means these panels are actually redundant. And they can go. As are these, to be honest. Yeah, so it'll be that one. Let's get rid of these a minute because they're on the wrong deck. So we want you on F deck floors. Right, and then this is the bit we need. What's all that stuff up there? Okay, that's the old door frame for the maintenance hatch, which I'm going to redo slightly. Yeah, that needs finishing off there. And on this side as well. Okay. Yeah, so we'll go, I think, straight across on the inside and just maintain the curve on the outside, which means in actual fact our door track there can be part of the framework. Hey, BC5. Not a huge amount at the moment, we're just fixing some of the wider issues with the demo update. Just polishing off various bits. Where else is that used? Oh, there, clearly. Good question, Elliot. We were talking about it earlier, and generally speaking, when it's done, but it's such a hard question because every time we think we're done, we find a couple of other bits that need doing. So I would say probably about a week. I'm 85 to 90% done with the tutorial update, and there's very little in the way of just tidying up to do on the ship itself. That aside, it's just bug fixing. So yeah, we're so close. We're so close that it's painful. So that should be 40. Genuinely can't tell whether that says 30 or 40 because my monitor's broken. I think it says 30. Oh no, because if that's 37, oh I see. It says 39.998. Okay. stupid broken monitor. I wouldn't dare measure anything in Claire's. I'd end up offending her in some way. Like, ooh, that gas giant's about half a dozen Claire's wide. And then I get a slap. Yeah, not for the first time. Hey announcer, how you doing? Nothing annoys me more than when a piece of geometry is like 0.001 of a millimeter out of place. Like this one is 0.008. Sorry, 0.008 of a centimeter out of alignment. It's not a distance you'd ever notice with the naked eye, but I know that it's there. Ah, thank you, Archer. I have a funny story, actually, and I can already hear Claire inwardly face palming. But I went and got my hair cut before going to Pitcon, because, you know, standing up on stage and all, wanted to look my best as much as I can. And I went to a like a proper barber's, and normally we just have a lady pop round to the house to do my hair and the kids' hair and everything. But she's not been available, so I just had to go out to a proper barber's, and it was an experience. I mean, not only did the guy cut my hair and like really go to town on cutting my hair, like just out of nowhere he shaved my eyebrows, like, and I was like, what? He just like got a brush and went zzz, like, why did you shave my eyebrows? Wasn't expecting that at all. And then he started shaving my back. Like, he had his hand down the back of my t-shirt with a razor, and it was going lower and lower and lower. And I was like, dude, are you going to shave my entire back? I mean, do I need to lie down for this? And he was like trimming my ear hair and everything, and like then he started like trimming the sides of my beard, and I was like, Jesus, that was like not bad for 16 quid, but was not expecting that. So I know where I'm going in future. But yeah, when he like came at my eyebrows, I was not expecting that at all. I was like shell shocked for the whole day. I still haven't got over it, to be fair. That needs cutting through properly. Yeah, it was definitely a full-on groom. It was funny, like for the whole rest of the day, I just kept going, he shaved my eyebrows. Yeah, they're not quite that long yet. Yeah, all normal ODST. I was just reliving the trauma of my recent experience getting my hair cut and my eyebrows randomly shaved by the barber. I'm still not over it. Yeah, exactly, Kaji. It's one of those things where, like, I'm sure to a person of my advanced years, that's probably a normal thing to do, but it's not something I'd ever considered needing to do. It was nice at Pitcon actually, because I think the average age in the room must have been around about 40. And it was nice being surrounded by people of a like age. I guess the term space dads exists for a reason. Now this edge is going to be awkward to fix. I need to re-chamfer these edges, but this one, I don't think I'm going to be able to just move it over because it's all on an angle. I did play the original Elite, yes. My one of my very first gaming experiences was playing Elite on the Commodore 64, and yeah, I loved it to bits. At 5 years old, there I was, unable to dock and having to get my mum to do it for me because I could never match rotation properly. Happy memories. So is it me or are all of these moving in the red direction? If so, then we possibly can move that over. Ah, joy. Okay. Right then, so we want, I believe it was 1.25 on these edges, if memory serves, like so. Clean up the weirdness. Actually, an amazing thing and also a tragic thing at Pitcon was that one of the raffle prizes was an original mint condition original Commodore 64 Elite box with all the book and the ship identification chart and all that is still in it, donated by Frontier themselves, and I didn't win it, which was, you know, as much as that's tragic in itself, the even more tragic part of that is that my copy of it was left behind in a house move by my mum, and I've never quite forgiven her for that. So not only did I lose my original boxed copy of Elite on a Commodore 64, I also didn't win it in the raffle. Curses. To be honest, everything I do today can really be traced back to playing Elite on a Commodore 64. It's, it's what started me off on my love of space sims and space exploration and sci-fi. So yeah, I have a lot to thank Elite for, I think. I've always hoped that David Braben would make an appearance at one of the Elite cons. I think that would be lovely, just to say hello. Well, from what I've heard, it is something that is discussed within the Frontier office. So he's probably seen it already, which is a weird, surreal feeling. Like, is it possible that one of my childhood heroes has actually played my game? I'm sure he's probably looked at it and gone, amateur hour, but still. It's the thought that counts. No worries, Hurricane, have a good one. I think I've made that chamfer too big there. Yeah, it should have been 2.5. 0.25 rather. Way too big. Yeah, I was chatting to someone at the convention about ship interiors, and how come we've got ship interiors and Elite doesn't. And I think, and honestly this is just pure speculation on my part, but I have a feeling that the Cobra engine can't do ship interiors because in order to have the player walking around the ship, you need to have localized physics within the ship. And I think in all honesty their engine's just not built for that. And I don't have a fleet carrier or anything, but from what I've seen, you need to be sat down when jumping with a fleet carrier. And I think that's probably an extension of that same issue, where because they don't have localized physics within the ship, you physically can't get up and walk around because they can't fling the ship around space and have you walking around inside it with physics. There would have to be like a Star Citizen style solution where they have local physics grids where each ship has its own physics state that gets moved around. So they'd probably have to do quite a big engine overhaul to support something like that. Again, that's just speculation on my part, but it seems logical that that would be the hold-up. And then not least of which, if you add ship interiors to one ship, you of course have to add it to all of them. And they've got, 70 odd ships I think you can fly? So, yeah, that's a lot of work. What's going on here? It's quite a straightforward answer, actually, Three Amigos, in that with Alcubierre drives and warp technology in general, the ship isn't moving. So you have basically localized geometry. The interior of the warp bubble is completely stationary space-time, and what it does is it compresses space ahead of the ship and expands space behind the ship to basically stretch the ship through space. So it uses compression and expansion of space-time itself to achieve FTL speeds. So the ship doesn't move. It is entirely stationary. Although in StarSim we're using the concept of warp bubbles not actually inputting any momentum onto the ship. There is a paper I read which was basically along the lines of, where does the velocity come from in a warp drive? And the point they were making is that no part of like the Alcubierre metric or any subsequent refinements of that, none of them deal with the problem of actually moving the ship. So that velocity has to be inputted from somewhere. So the way we're doing it is that the ship has to be moving already for FTL to work, and it simply amplifies movement along that vector. So you use the sublight engines to give the ship momentum, and then the FTL drive amplifies that momentum in the direction of the field. Why are we stuck with that edge? What's going on there? Yeah, so we needed some kind of sci-fi material for the FTL rings, because the FTL works by using mass energy equivalents, and as does the artificial gravity. So the idea behind that is, by using E equals mc squared, you can convert energy into mass, which obviously also creates gravity. So by inputting enough energy, you can create enough mass, which not only creates a gravitational effect, it also curves space-time. So the artificial gravity and the FTL drive are basically two sides of the same coin. It's the same technology, it's just that the FTL drive is using much more power and creating a much bigger field, whereas the artificial gravity is just per segment per deck, just creating a local approximately 1g of gravity. Now, in order to create I think it was 1 gram of matter for 1 second, it was something like 1 terawatt of energy. I mean, that's mental, like an entire terawatt to create 1 gram for 1 second. So if you think about how many grams of matter you would need to create 1g of gravity, even within like a couple of meters along a corridor, you're talking like gazillions of terawatts of energy just to be able to have enough gravity to hold a human down. So we need some kind of sci-fi material which deals with that problem for us. So we're going to have some kind of crystal or some kind of mineral which, when energy is applied through it, it amplifies that mass energy equivalence. So you get a lot more mass for a lot less input voltage. And that's the only way that kind of makes the whole thing plausible. Yeah, definitely try him. The way I'm approaching that Oni Noni is that if you think about the FTL field, so you've got that forward direction where the field is facing. So its maximum effect is in the direction of the field. If your prograde direction is off axis of that field, then the amplification effect of that field essentially gets less and less and less, and then becomes 0 at 90 degrees. So, if you're completely perpendicular to the direction of travel, then the FTL field is doing nothing. So what you can do is slowly move the ship at FTL, but make sure that your prograde direction is always aligned as much as possible with the FTL field. So when we're simulating this properly within the game, you'll probably find that when you move the ship, you slow down. So we'll have to have that track, and maybe have the field angleable in some way so that we can offset that slightly, so that you can do space drifting with the ship. Yes, hit my day today. That's exactly what it will be. So once we have all of the artificial gravity stuff properly simulated and properly working, then when you do the cold start tutorial, yes, that will be in 0G. So we'll either do mag boots or literally floating down corridors. And then when you do the initial power up, the first thing you'll power up is the artificial gravity, and then proceed with the tutorial as per normal. The autopilot's technically already doing that. So when you are facing away from where the autopilot needs to go, it will actually slow the ship down by a percentage of how far off of that axis you are. So basically it works out which vector you need to face in to reach the target destination, and then it reduces the ship's throttle by a percentage until you reach 0 at 90 degrees. So if you're facing the wrong way, more than 90 degrees away, it essentially zeroes out the throttle to allow itself to turn around. It doesn't work entirely as well as it should, but that is what it should be doing. That's what it's programmed to do. Right, there we go. That's the door track for the hatch there. I'm just wondering what on earth is going on with this. It's fairly confident that there aren't any really close vertices there doubling up. And yet there must be. See, now it's saying that one's, or is that the same one? Yeah, it's the same one. Okay. Which end of it's messed up? That's the question. Normally you can just kind of of select around it and then delete whatever you've selected, but there's nothing there to select. It's because it didn't have soften coplanar turned on. That would explain it. That's because I can't see it. It kind of says like suffocoplanar on my screen. Again, my monitor's broke, so I can't read anything like below halfway down the screen. Okay, that's more like it. And then with this being the rear one, I need to just make a wall. Yeah, when it comes to the mysterious FTL material, and indeed artificial gravity material at that, I like the idea of discovering that somewhere. So it is like a raw material that exists in the galaxy that we've come across, and its discovery has enabled the technology we're using, which gives rise to the ability to then find more of it in the galaxy. So if it's not something that's manufacturable, then that makes it a valuable commodity, and perhaps valuable enough that other races also want it and will be willing to fight for it. Like dilithium or naquita. It's the same kind of thing. It's like a miracle substance which is rare and highly valued. But yeah, I do prefer finding it rather than making it. Nothing that happened in Discovery is real. I can't do it, no. Okay. So that gives us a door with a window each side on both sides. And this has the added benefit of also working for crew quarters as well. So the crew quarters on D and E decks will also have this same arrangement with a door in the middle, which means we can copy paste up and down between the two of them, which is always a benefit. Speaking of which, I think I might already have that exact bit that I need already done on D and or E deck. D deck frame walls. 1, 2, 3, 4, 5, 6. No, perhaps not. What's this one? 1, 2, 3, 4, 5, 6, 7. No, right, no, I don't. Curses. Although this does create quite a weeny corridor bits there, which means a 7-panel segment. So what's this one again? This is 1, 2, 3, 4, 5, 6. Right, so 6 segments creates a panel, which is 2 point whatever that is wide. I'm guessing 2.21. So 2.21 meters, and that's well below the 2.5 meter standard size. So in actual fact, I think we're better off using 5 segments rather than 6. And then just offsetting, yeah, just not having a bulkhead basically. Because the problem with making this panel any smaller is that you can't fit a door in it. Which means we need to take a copy of this. And again, yay for standardization, because we can just copy paste stuff around as needed. So we pop that down there. Let's leave that there for a minute and just get rid of these ones. Okay. Grab that lot. Rotate 90 degrees, cut, and paste. Right, so we've got the same deal, so this still lines up. We've still got the wall in the middle, it's just we have less segments. So we can still have the door in the middle, we just don't have that extra middle segment to worry about. Which means that I need to move that over. And we need to sort out that. So let's get rid of that for a minute. And then we need to replace these with these. 1, 2, 3, 4, 5. Nope. 1, 2, 3, 4, 5, 6, 7. Definitely not. 1, 2, 3, 4, 5. Right, I need a 6 panel template I can nick from somewhere. Do we have one on F deck? One, 2, 3, 4, 5. 1, 2, 3, 4, 5, 5, and 5. Okay, what about C deck? actually. 1, 2, 3, 4, 5, 6. Yeah, there we go. Right, so we'll grab that one. And then rotate 90 degrees. And then stick it on the right level. So that's G deck template. Okay, so that one and that one need to move. So we go from there to there. Then that one and that one need to move. Sorry, not that one. That one. From there to there. Right, so we should still be aligned. Yep. Z fighting tells us we're aligned. Num bum. What are we doing time wise? 2 hours. It's a bit early for num bum. That doesn't usually kick in to at least 3 hours. Right. That should be everything we need to do on the framework other than sorting the door frame out. Ring 1, framework. G deck, aft walls. G deck, framework, aft walls. Yeah, definitely, Kaji. So the tutorial pathing will actually work for once. Okay, well, thankfully we don't need these sockets anymore, so they can all get deleted. This is how I had to do it before we had the snap guides. So I had to have specific sockets in place all over every framework piece in order to snap the panels and things to the walls. But with the floor-based snap guides, that's no longer a necessity, which just speeds everything up generally. Okay, ring 1, framework. G deck, framework, aft walls, I think. That looks right. Yeah, there we go. so the start capacitors room, which is now the emergency power room, is on this side, and equally sized is the workshop / 3D print area for engineering on the other side. And I will have to redo the doors because the doors are now curved. Apart from this one. This one's not curved. Although it does need its door track removing. So let's do that as well, actually. Because we don't want the door cassette. In fact, is that... yeah, it's on there, so... It used to be the case that when I was making doors for the game, I would include the full door cassette like as part of it and everything. I'm no longer doing that because technically that should be part of the framework. So that bit is not needed on the doors. So of course we were probably referencing that somewhere. And that just fits in the door track. Okay, and then we need to re-import this one as well, because obviously that's now wrong. So that would be GDEC framework walls. Did I do it as forward walls? Yeah, I was thinking something along the lines of like supernovas, and obviously supernovas create heavier elements. So the most recent supernovas must be creating the juiciest elements. Obviously every star that's made of supernova stuff is made of more and more metals. And when those go supernova, they make even heavier elements, and so on and so on. So one would assume that over millennia, as stars die in supernova, the number of heavy elements in the universe will just increase. This one's got a bunch of sockets we don't need as well. Okay, so did I not? Let me just make sure that that does indeed have a door cassette. Oh, it's not on the level. Not in the group even. That would explain it. sadly there's no select all on this, you have to do them one at a time. Right, let's clean that up a bit. Right, so 1, 2, 3, 4, 5, 6, 7. Yeah, okay, so this was the experimental one I did, which works out nicely on this side of the corridor, but not so much on the other. So the other possible solution I was looking at for this was to have, like in the only place on the ship, a different number of panels on that side compared to this side, which wouldn't be impossible. Might make the ceiling a little bit awkward, but I shall have to see. Ultimately might prove to be the only viable solution to the super wide windows problem. Ugh, look at those horrid normals. Let's just fix them in a minute. Okay, so the outside is now smooth, the inside is now smooth. Need to do an end piece for that. Why isn't that lined up? Something needs fixing there. Oh, I see, it's still the old curve. Yeah, so I need to fix that bit as well. So all these little bits. So yeah, as we're going around, just finalising all the various areas, I just keep coming across little bits like this that haven't been done. Do you mean here? This is just some of the default stuff. Nothing's loaded yet. Spit and polish airikes, just finishing all the little bits that needed finishing. I think that needs a door hole now. Okay, so now that we've got that, do we have a 6-piece? 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm assuming there's going to be none of those on F-Deck. So we've got 1, 2, 3, 4, 5. 5 there. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Right, okay, so we do actually need one more panel down for G-Deck, which is the 6 segment ring 1 curve. I'm assuming, yeah, the snap guide is already operating on that assumption. Let's just turn that off a minute. Yeah, so the snap guide's already assuming that there'll be 6 panels there. If you mean giving planets your own name, then we will be doing that at some point. There will be basically a ship's database of stars, planets, and various other bits and pieces. In addition to saving points of interest for future retrieval, you'll also be able to apply your own name for an object locally for your save game. So if you find a particularly cool star or particularly cool planet, you can name it within the context of your local game or your multiplayer save game. So anyone that joins your server will see what you've named stuff. So I'm just questioning, for my own sanity's sake, do I go ahead with 7 segments here, but have 5 for the inside edge? So if we were to keep 5 for that, maybe. Although it does make it huge on that side. I'm just thinking of the ceiling panels. So obviously the ceiling panels are that bit in the middle. We don't want them to be too big either. And that one's already way bigger than it needs to be, but it will do. Yeah, I think I will. I will. It's stepping off script for the design kind of rules for the ship, but it really is the only solution that's practical. And we'll just make sure that the interface between the wall panel and the ceiling works. And when it comes to things like damage and fire spread, which is the reason for the segmentation in the first place, the way it's going to work is that, looking at it from this side, if this segment is on fire, for example, then this wall panel and this floor panel will be on fire. That's how that's going to work, and that will then spread to this segment and to this segment, so that fire is then spreading throughout the ship. And by doing that in a segmented way, it makes it easy to manage on a logical level. Now, if we've got offset panels on this side, then we basically just have to pick and choose which segment they relate to. Like that one's obvious, that can connect to this segment here. Like that one can connect to that one maybe. And then it's just this one, we just have to basically pick a segment that it's connected to. I guess it would be this one because that's closer. And that one can connect to that one. So it makes it a little bit awkward for dealing with some of that stuff, but at least it gives us wall panels that are a reasonable size and it still fits the door frame, which is the important part. Which means we need to cut a hole in that particular one. So where are we here? So yeah, that's the forward one. So that one there needs to be unique. We need to get rid of that. Grab the top. Copy that. Delete the rest. Pasty and extrude. Autosave. Yes, fair point, Anasi, and I'd like to get to that fairly soon. I suppose we'll be doing moons and such reasonably soon into the future, so I guess that will be when we do that. Yeah, because I'm just thinking, I was talking to Claire about this, so on our long drive back down from Nottingham, we were just kind of going over the patches and kind of the order we wanted to do things in, and we agreed with one another that we don't want to think further ahead than 3 patches in terms of deciding what we're going to work on, because circumstances change and that doesn't leave any room for pivoting or reacting to something. So the next update's definitely going to be bridge crew and a couple of bridge bits tidied up, and then we want to look at the sublight side of things, and we got a bunch of stuff which is all kind of interconnected there. So there's a few chicken and egg problems we've got to deal with. Like, we can't do the sublight side of things without properly addressing kind of the moon side of things, because in order to do sublight we need to work on the collisions, and right now we can't have collisions for planetary bodies because of the way they move. So in order to solve that, we need to do the code that puts them in the world properly, and whilst we're doing that, that's kind of related to the fact why we can't have moons in the first place, which is that the data structure doesn't allow for it right now. So we have to fix that data structure before we can do sublight. So kind of sublight and moons, they all kind of come at the same time. So, and I can't remember off the top of my head now the exact order we were going to do things in. We did write it down. But we're going to split some of the next updates into almost like micro updates. So the 226 patch cycle with the bridge NPCs, the ability to interact with the holo display, doing the bridge ceiling properly, and a couple of other bits. That's going to be probably larger than the ones that follow, and then we're going to do some pretty rapid small patches to address some of the individual kind of like precursor requirements that we need to address before we can add some of the bigger features. So we want to get those little core bits done. But yeah, so expect some rapid patches once this all gets done. Yeah, so the way the Bringe NPCs are going to work is, and we also kind of went through this as well, kind of like virtual gameplay just in our heads. As the captain, you need to be able to issue commands to NPCs and kind of voice what you want them to do. So we're going to have the holo display become interactive. That's kind of like the main way that as a captain or commander, that's how you kind of interact with the crew on the bridge. So you'll step up to the holo display, you will physically touch the star that you want scanned or you want to see more detail on, and once you have selected that as your command target, you can then turn to either the sensors guy and say, do X, Y, and Z with my command target, or similarly, you can go to the helm guy and say, plot a course to my command target. So in the same way that we have a sensors target that can be accessed on the helm, we'll also have a command target as well. So both the sensors and the helm will have some additional buttons to cater for that. But in addition to that, you'll also have a context-sensitive radial menu that pops up when you look at an NPC and press F. So obviously those NPCs are there for testing in this initial version. So the idea is you'll be able to walk up to the helm chair or walk up to the sensors chair, and when you go to press F to sit, instead of just sit, you'll have a couple of other options for spawning an NPC. So you can walk up to the sensors, and instead of sitting, you can choose spawn NPC, and that NPC will then sit there and essentially wait to be told what to do. If you then want to sit in the chair, you can despawn that NPC and it becomes a normal chair again. And the same applies to the helm. So you'll be able to spawn the helm or the sensors NPC in and out as needed arbitrarily. And then as the captain, obviously you can then tell them what to do. They won't be sort of autonomous yet. So you will need to issue commands to them for them to do something. But it's just basically a proof of concept of how we're going to handle that NPC interaction on the bridge or in the bridge environment. Yeah, that would be good, Jason. Oh, I'm still scarred by the full Boimler. And yeah, actually, the third thing to add to the NPC side of things is also the ship's computer. So we want the captain to be able to audibly issue a command to the computer anywhere on the ship. So, if you're in engineering, for example, you should be able to just speak to the ship's computer and say something like red alert, or drop us out of warp, or something like that. You should be able to speak to the ship's computer and issue commands. So we'll have the facility to do that as well. Again, it'll be by way of a radial menu, I expect. So you'll bring up the ship's computer commands, and then you'll navigate to which command you want to issue. We will, of course, play test the hell out of it, and if something's too clunky or something doesn't work the way we want it to, then we will change it and improve it and refine it, because that's what we do. Everything's iterative, everything is subject to change. Yes, CSI. Right, that's the other thing we talked about, actually. So, yes, there will be 3 command codes. One for engineering, one for command, and one for internal security. and each of those codes will give access to different things depending on what those things are. So obviously the engineering command code will work on engineering stuff, whereas the command, like senior officer command code, will work on everything, and then the internal security command code will work on doors but not engineering hardware. So we'll have like a tiered approach as to what those codes can and cannot do, and then we will set things up accordingly to make sure that that works. Yeah, that's a good point, Erix. So talking of command codes and being able to lock down important things on the ship, that kind of comes under like ancillary items for a patch. So what we want to do is basically we want a wish list of all the stuff that either the community are asking for or stuff that we've identified that's needed. And we'll have this massive long wish list of stuff, like keybinds, Welper, if you're listening. And every time we work on a patch, we will see how many things from that wish list we can get into that patch between obviously finishing the main patch objectives and releasing that patch. So we might get between 2 to 3 of those wishlist items into that patch depending on how we're doing for time, or more if we're doing really well for time. So we will have a constantly updated wish list, and we can prioritize that based on feedback from the community. I always find that's the best way to do things. I liked a system we had a while ago where we had the community vote on what they wanted us to work on next. We can't really do that at the moment with with the timescales we've got, but that is definitely kind of something we'll look at. Yeah, definitely. It's I'm just plodding through one thing at a time. Yeah, I think I've got it in my head, Seamus, exactly how we need it to work. It's just a case of realizing that in actual gameplay in a way that works, because what you think works like in theory doesn't always survive the test of actual being played in anger. So 7.4. So each segment should be 7.4, so 7.5, 7.5, 7.5, 7.5, yeah, okay, that works. So you go there, you go there, you go there, and you go there. To thicken that one to
And then that distance should equal the other one. That's like 5.5. 4.5. Okay. That one's 10, so that's a good point, actually, Seamus. Yes, we need the Claire stream again, definitely. That should make sense now. So we've got the actual metal work bits there. You've got the cut line in the middle, which means that needs to be that way round, that needs to be that way round, and then all of that can intersect once that's exploded. Of course, actually. So just remember an important point in that I need to not cut it all the way through the floor because we need the internal curve. Should be more like it, and then we should have a slight gap under there. Okay. Right, so that's our door track there. Don't need that bit or that bit. Never remember on this which bits I'm deleting or keeping. So I know I need to get rid of those. And then we've got, so I think that should be 2 to there and 0.5 to there, and then that's the floor. Yeah, so I'll draw the floor across there, which means shouldn't need those. Right, let's edit this up out the way.
no, actually I need the bottom, don't I? Of course. Right, which means that and that are not needed. Which means that. And that. No, I do need this joining one here. Okay. Right, so I do need that one. I don't need that one. That one can go. And that one can go. Which means I don't need that. I do need that. Don't need that or that. I do need that. Okay. Right, now I need to separate all these out into their corresponding bits. Okay, that's one side. And that's the other side, and I'll add that to that group. And explodey. Which leaves us with this one, which can also be a group. these edges out, and then to do that I need to grab that and that, and then paste them in place and reverse their faces. Okay, which means I can now chamfer the edge, bevel the edge even. Fingers crossed nothing went weird. That all looks good. Same with this one. All looks good. Okay, so that one, that one, that one, and that one. Curve the edge a little bit. Do that so we can pick up some light bounce. And the same on this one. Okay, that should be job done. Hang on, got some faces in there, I suspect. Okay, one door cassette. So this was GDEC forward. Okay, now we can restore that door hole. And as always, fix these disgusting normals. Okay, so the door is going to need redoing because we have a straight door in a curved hole. That's kind of like end step stuff. So at least you can get in and out of it. That's the main thing. Right, which means that those panels are wrong. Right, so if we keep the panel size relative to the inside, that kind of matches the rest of the corridor then, because obviously the bit where the stairs are 5 segments, so we'll do the 5 segments aligning with the middle, and that also conveniently lines up with the door stuff that we already have in there, which means we can go ahead and do the 5 segment sized window frame for there and the door frame for there, if we haven't done it already. Oh, I've done that one. Hang on, let's confirm. appear to be one. So G deck interior walls, which is the one we're on. So we copy that down to there. That should fit exactly where we want it to. Yep, that's lined up, that's lined up, that's lined up. Yeah, there we go. Exactly where we want it. So we just need the window frame, which I haven't done by those things. Yeah, so we need a window frame for there, and that finishes that curve. And then we need we need the 6 segment for here. Okay, yeah, so if we're sticking with 5 for the inside edge, then I can actually just copy them down. So if I turn off the snapper watts in a minute, because it will mess up otherwise. So what are you? So is that minus 1700? Cannot read that at all. That puts that there. Puts that one there. Then we need to put that one in the right place a minute. So we need fdeck snap guides. Snap that there, turn that back off. Pop that down there. Pop that down and that one. Well, it's a good question, Kaji. Right now I haven't ordered a new monitor because I don't know whether I can do like an RMA on this one, because this monitor is only 6 months old, if that. So, you know, it's kind of poor that it's failed already. It's a gigabyte monitor. I can't remember where I got it from. It was either Scan in the UK or maybe eBuyer. I'll have to go back through my emails and figure out where it came from. So I might be able to send it back and get a replacement. The other two are fine, it's just this. Typically, the one I actually use the most is the one that's gone wrong. I'll sort these out for Claire, otherwise she'll shout at me for messing up her stuff. I'll fix the visibility in a sec. So that should actually be 4, I believe. Oh, that's good to know, AJ. Thank you. I had a weird thing with Scan actually. I had an account with them which went back, well, decades, literally, back to the 90s, and for some reason it's just vanished. Like, they don't have my account details on record anymore, which was really weird. Oh, that sucks, Retia Callum. Actually, I had a really big problem with Scan once, in that I ordered a bunch of computer stuff. This was a couple of years ago now, and the CPU box came without the CPU in it. So the box itself had like sellotape across the top, so someone had obviously taken the CPU out and sellotaped it back up. And I called them like within an hour of receiving the package, and they just flat out didn't believe me that there wasn't a CPU in the box. So I said, well, prove to me that there was. So they sent me this really blurry, grainy image of the guy packing my parcel in their warehouse. Like nowhere near enough pixels to see whether there was a CPU in the box or not. And in the end, they just said, I'm sorry, we can't help you. As far as we're concerned, we gave you the CPU. In not so many words, we don't believe you. So of course I didn't leave it there, and basically said, well, either you give me my money back or a CPU that I actually purchased, or I'm taking you to court. And then like a day later, or that same afternoon, I can't remember now, I had a call from funnily the same woman that was calling me a liar, in not so many words, basically saying, oh, sorry, it was all our fault. The item that was packed came from the wrong shelf. It was a return shelf. So, oh, really? Well, funny that. So, yeah, they sent one out next day delivery and apologized, but beyond a curt apology, I got nothing in, I didn't get any compensation for my trouble or any like apology for flat out calling me a liar. Other than that, Scan have been wonderful, but yeah, I just had that really bad experience with them that one time. Yeah. Yep, I have heard them called that before, but I mean, Scan were always my go-to company for computer parts for many years, literally decades. But yeah, it's just a shame that on this one particular order that they screwed up, they yeah, had the nerve to blame it on me. So, and from that point on, every order that I've had from Scan, I have recorded me opening it. So there can no longer be, any accusations of foul play. I think when they came up with the name, that wasn't really a thing. I mean, my first interaction with Scan was definitely in the 90s, like a long, long time ago. And then I remember going to a LAN party, and I can't remember whether it was late 90s or early 2000s, but Scan were actually sponsoring the LAN party, which was really cool. So we hired out like a hotel conference room thing, and Scan were there, you know, supplying bits and pieces, which was cool. It was really funny actually, because there must have been, I'd say, a good 300 to 500 people there, all with their computers, all gaming. And of course I drove up with my mates, so there's like literally 4 of us in the car, all of us with like massive monitors and PCs and things. You know, this is way before the days of flat screens. They're all CRTs. So we literally, other than me, and all my stuff was in the boot, and everyone else had to carry their monitors on their laps for like 4 hours driving, which was funny. But yeah, we had this moment where the network in the LAN party was just slowing down and lagging more and more and more, and they announced like over the tannoy, "Will people please stop torrenting each other's stuff over the network?" It's like everyone was just sharing everything they had over the network, and it just turned into this massive piracy session. Ho hum. Happy days. I didn't, sadly, no. I've only been to a couple of LAN parties in my life. I do have a claim to fame, though. I was invited to the actual house of the UK Quake champion, who lived in London. And yeah, that was really cool, because I was into the Quake scene at the time. And this was, I think it was around about the time of Quake 3 Arena. It might have been during Quake 2, but around about that time period. But yeah, we actually went around to his house and kind of had a bit of a LAN party in his lounge. So that was awesome. I was quite good at Quake back in the day. Yeah, it would have been around then. I left school in 95, 96. I remember being blown away with the very first Quake demo. There's like this one moment in the demo where like one of the mobs, I can't remember what it is now, comes like bursting out of the floor in front of you. And you know, before Quake came out, you know, we were all into Doom and Wolfenstein. So to have an actual proper 3D first person shooter where stuff was like literally coming out of the floor in 3D in front of you, it was just like mind-blowing. Kids these days, they just don't know what luxuries they have. voodoo cards. That's taking me back. And the ever trusty Matrox Mystique. That was one of my first cards. Whatever happened to Matrox? Actually, that's a good question. What happened to Matrox? Matrox Electronic Systems Limited, the former parent company, sold to Zebra Technologies as part of the divestiture of Matrox Imaging on June the 6th, 2022, and succeeded by Matrox Graphics Incorporated. Oh, they do still exist. Wow. They are now Zebra Technologies. I've literally not seen them produce anything like since the 90s. Makes sense. Funny, you know, I always kind of lament the fact that I was born too early, because there's, you know, so much cool tech coming out and so much stuff on the horizon, and you know, we're finally, you know, entering the space age, or at least we seem to be. And I think to myself, oh, you know, I wish I was born, you know, 20 years later so that I could truly appreciate all of that stuff. But you know, at the same time, I'm kind of glad that I grew up without the internet, and I'm glad that I got to see the internet become a thing. You know, it was a transformative technology for humanity, and I was there when it all started. You know, I remember life without it, so then that's kind of cool. Yeah, the days of internet in the UK costing 1p per minute to use, and getting kicked off the internet because my mum needed the phone. I think the internet is both the best and worst thing to ever happen to humanity, probably in equal measure. Yeah, exactly, Delta. I imagine the internet will probably turn into the communication highway for AI, and I can absolutely imagine some kind of crazy AI broadcast storm where you've got so many AI agents all trying to do stuff that it literally crashes the internet because there's just that much data being generated. Or that much traffic, rather. Almost forgot the bolts. It's funny you should mention that, Erix, because I always thank the AI, and I always say please as well. And I feel stupid doing it sometimes, but I don't know. It responds in kind, I find sometimes. Like, if you're speaking politely to the AI, then it kind of, responds in that same way to you. It's like a little bit less curt. But yeah, I'm just preparing for when our AI overlords take over, so they'll remember that I said please and thank you. And I'll be safe and saved from the human slaughter that then commences. And another floor panel. Am I sick of floor panels? Yes, yes I am. It's funny. I have this conversation with AI. No, not with AI. With Claire. Claire's not AI. She's real honest. Yeah. So I have these conversations with Claire, and we'll talk about AI and the pros and the cons. And Claire's very much of the opinion, at least she was last time I spoke to her about it, that the pain is not worth it. Like the pain and the disruption and the trauma that AI will inevitably cause as jobs are lost and the way of life changes, that's going to affect our kids. You know, they're of that age now, being teenagers, that they're going to live through the AI revolution. I mean, it is a second industrial revolution that's happening. You know, we've got not just cognitive AI, but we've also got AI embodiment as well. We've got, you know, what will rapidly become billions of very capable robots doing manual labor. You know, the job losses are inevitably going to be extreme. And my argument's always been that, you know, universal basic income will save us. But as Claire perhaps more correctly points out, that our governments are useless, and if UBI ever becomes a thing, it won't be a thing soon enough. And there will be a lot of suffering before anything like UBI is eventually brought out. You know, too late as always. But I think, you know, my opinion on it is that eventually the pain will be replaced by a better future for humanity. I think, who pointed it out? Can't remember who it was. Someone just pointed out that, you know, humans suck at running themselves, and it's true. Like, our government sucks, and, you know, pretty much most governments are ran by committee and therefore suck. And AI can just cut through the crap, cut through the committees, and work on pure logic to do what's best. And humans aren't very good at that because they're very biased and self-motivated. So yeah, I would happily accept a super intelligent AI overlord who I could, you know, trust was more intelligent than me and could think about things on a level far above my understanding, and I could just trust that it knows what it's doing because it's all clever and all. But yeah, I do agree that there is going to be a pain period whilst we readjust to this new world. And I think that, you know, the general public, like most people, don't understand or appreciate just how much the world is about to change. I mean, it's going to be a massive wake-up call for humanity once AGI and then ASI, you know, really gets established. When we've got literally thousands of AI agents doing all of our cognitive work for us, then you're going to suddenly find a lot of people without jobs. And, you know, like I said earlier, it is the case that right now AI does require a human in the loop. It can't do it on its own. You know, it's not particularly capable, but that won't always be the case. Yeah, I'm fascinated by it, and I'm following the development of AI, and like I said earlier, I want to stay ahead of the curve because, you know, it's one of those sink or swim things. You know, either you keep up with the tide or you get drowned. So, you know, as a business owner, I need to make sure that we act proactively. Yeah, I don't think there'll be many people that aren't affected by AI. I mean, right now it's all fun and games and, you know, making pretty pictures of cats, but it's that cognitive work. It's that, you know, when we reach the point of AGI, which is so soon. I mean, we're almost there already. You know, if you look at some of the AGI benchmarks, you know, some of the most recent thinking models really are very close to AGI. I think for me personally, and I know that the definition of what is AGI is a very vague one, and no one really fully agrees on what that is. But for me, it's that C3PO moment where an AI, embodied or not, can think continuously. So not just at prompt time, but when it's not being prompted, it can actually sit there and think about stuff and you know, come up with thoughts of its own. For me, that's AGI. That's like a proper intelligence. When that happens, the world is going to be a very different place. It's true. And hey Ranzer, all good, thank you. yeah, we're just chatting about AI randomly. Yeah, I mean, the other thing is that people keep talking about AI slowing down and AI plateauing, and every time someone says, oh yeah, that's it now, AI's plateaued, you know, we're limited by this, we're limited by that, it just blows through it a week later. You get a new model comes out that completely invalidates that statement. And the you know, the exponential growth curve of AI is still accelerating. You know, if you look at like cognition per dollar, it's getting lower, and you know, it's still on an upward trend. So that's that bit done. Right, so we need to sort out that door hole. And then we need a 6-segment version of that panel and that door frame. Then we need to sort that out. So what's that? 1, 2, 3, 4, 5-ish jobs to do here. But that'll be this bit done. I won't bother with the interior paneling. I'll do that after the demo update, because obviously we are at a point now where we just need to get it out. So sooner we can do that, the better. That at least fixes that section there. Thank you, Ranzer. I say that a lot, Zoke. Like, every time, you know, I look at something with AI, I think this is the worst it will ever be. And, you know, I've been saying that for a year now, and it's incredible just how much it's improved. Like the other day, Claire was playing with Meshi.ai, just, you know, making random stuff for the fun of it, and she made this like little cute gremlin, like little creature, and while it looked great, the UV mapping on it was, oh my god, it was atrocious. If you imagine like camo paint, that's what the UV map looked like. It was absolutely awful. Like nobody would do a UV unwrap that looked like that. It was truly horrible, and the fingers were like all mangled up. and like, yeah, the bones are in the wrong place. He tried rigging it, and the bones are in the wrong place, and it was a passable attempt at making a character, and it was usable in the vaguest of senses, but no professional would ever produce something as sketchy as that. It was awful. But this is the worst it will ever be. And, there will be a time, probably a year from now, like probably no more than 2 years from now, where you can produce good, properly UV unwrapped, fully rigged character meshes in seconds just by typing a prompt. And things like that are going to have a huge impact on the industry. And for what we're doing with the game we're making, we're perhaps placed at an advantage because we have an entire galaxy of alien life, of alien cultures that we want to produce. And we're doing that through procedural generation. But if we can transition over to AI generation, when it becomes actually good, then that means we can fill our galaxy with truly unique cultures that are fully embodied, with like thousands of years, millennia of backstory automatically already there, with love stories and sonnets and artwork that are all generated on the fly using AI algorithms, which would make our galaxy no different than exploring the real one. I mean, you come across a culture, and that culture is fleshed out to the point that no one person could ever flesh it out. Where you could spend like months of your time just exploring a single culture in the game, learning their histories, learning who their great poets were, reading that poetry in their language. Like, all of that is possible, once AI reaches that point. So, a few years down the line, maybe 3 to 5 years, we could have a really, really very fleshed out galaxy. And I find that exciting. I'm excited by the possibility of that, about flying to an alien world, meeting that culture, like bringing up their actual artwork, their actual works of art, listening to their actual music that was created by that culture. Obviously all generated by AI, but with the illusion of that within the game world. It could make for probably the deepest exploration experience there's ever been. So yeah, I'm all for that, providing it runs locally within the engine. That's my caveat. But yeah, we still have a long way to go. A long way is probably only a year or so, but yeah. At the moment, minor, yes. I think AI has become a dirty word. And when people think about the use of AI, especially in creative circles, like in video games or artwork, people go, ooh, AI, no, that's bad. And right now, yeah, it is, but it won't always be that way. And a lot of people who are against AI in principle are, it's a knee-jerk reaction. Like it's that whole echo chamber thing that everyone hates AI, and it's a perpetuating thing where that. I hate to use the word cancel culture, but it's kind of like a cancel culture type thing where it's trendy to hate on AI. And, there's definitely an element of that. Like, there's an undertone of that. But, yeah, there are elements to AI which are positive, and you can be creative with it. You don't have to let it do all the work for you. You can still be in control of that creativity. And, I see it as kind of conducting and orchestrating what the AI is doing. But yeah, it's not AI now that I'm excited for as such. It's AI in a few years' time that I find intriguing, and what the possibilities are for this game specifically. Like I said, if we can have like properly fleshed out cultures in the game with millennia of history behind them, all unique, like completely unique within the galaxy, then that's going to make exploring the galaxy, an extremely fascinating experience, because every culture will be so unique. Yeah, you're right, Fantasy. It's, and obviously they do experiments with that as well, where they will purposefully feed AI with bad stuff just to see how it responds. What was it I was reading that I was watching the other day? Oh, it's something about like the Golden Gate Bridge. So they purposefully trained this AI to be obsessed with the Golden Gate Bridge, and it's like every response that it gave, it would go, just like the Golden Gate Bridge, or have you considered the Golden Gate Bridge? And obviously, that was an example of how you can break an AI or cause like an AI to have mental problems by the way that you train it. And obviously by doing that, you learn how not to do that. Now that's how you learn how they work. And I think the fact that most people don't know how they work is definitely something that leads to a lot of anxiety. Although we truly don't know how AI think yet, it is still a mystery black box, and that is a genuine concern, because it's oh, my live stream just crashed. No, it's because I mentioned AI. Look, it crashed the stream. I think we're back. Are we back? But Clover, yeah, you're right. AI slop is what people hate. Like it's already happening where, like, I think it was in the last Steam Next Fest, before the Steam algorithm sorted itself out. In the Next Fest, there was just like loads and loads and loads of AI slop, and yeah, that's naturally going to happen. Because as it becomes easier to create code and to create content, people are just going to be just spamming the market with just AI generated nonsense. And that will improve over time, and it will be less nonsense over time. But there is going to be a period where we just get absolutely overwhelmed by just trash, just constantly regurgitated AI rubbish. And yeah, that is a genuine concern. But I think that's a temporary problem. I mean, as a game developer, yes, I should absolutely be concerned for my job. But I guess for me personally, I'm working on a passion project, and I have lots of plans for this passion project. So I'm not in the same boat as a typical developer who is kind of fighting for their career, making a series of different games. I'm just focusing on this one thing. But yeah, I think we've gone way off tangent. But yeah, as you can probably tell, I do find the whole subject of AI fascinating, and yeah, it's an intriguing thing. It's amazing what it can do, and I think back to the teenager me back in the 90s and what we had technology wise back then and what we have today, and it's just mind-blowing. But then I've always been a technology enthusiast. It's what got me into computers in the first place. Right, on that happy and slightly weird note, it's coming up to the 4-hour mark, and I think that's probably a good place to leave it. because the num bum is now extreme, and it's got really, really hot in the office for some reason. So I need to go and open some doors. So thank you everyone once again for watching, and oh yeah, I was going to play my talk, wasn't I, from Pitcon? So if anyone's up for that, I shall quickly find it and put it on.
There's a...
Oh, yeah. I happen to have found exactly the right bit, so that's useful. Okay, so the video quality is not great. I shall full screen that a minute. I did say my presentation, Claire, yes. We might be able to split it out. I don't know. This was the live stream that happened on the day. I was just thinking, wow, that's really bad quality, but I forgot my monitor's broken. Right, I shall say goodbye and mute my microphone, but I'll play this until my bit's over, so you can just admire me in my shorts, which is going to become a thing, apparently. I'm now no longer allowed to do any presentation unless I'm wearing shorts. Do you think so, Claire? Hang on, hold fire. Claire has spoken. Oh, snipping it, yeah. Sorry. I thought you meant don't play it. Okay, so with Claire's blessing, let me just work out how to do this with obs without breaking stuff. Doobie-doobie-doo, so we want to hide that one. Yeah. And then I think I'll just mute my mic because it's coming through the computer stream. Oh yeah, music. Thank you, Minor. Okay, stop that one. This is a well-oiled machine, obviously. Right, let's give this a try a minute. Yeah, I'll just leave it running. Hang on, I'll talk over it for a minute once we watch me getting ready. So, in case anyone's wondering, this is me doing a talk on how and why we do the galaxy the way we do within Starship Simulator. Obviously, I was very nervous when I did this, so you can kind of hear me just babbling like a lunatic at the beginning. But apparently I do calm down and speak more slowly as it goes on. Yeah, let's see if I can speed that up a little bit.
Hello, Pitcon.
Right, good night all.
All right. Ladies and gentlemen, it's my very great honour to present Mr. Dan Govier and Starship Simulator.
Thank you. Hi everyone, and thank you for attending my TED Talk. And I'd like to thank
my beautiful assistant, Burr, who will be doing the button pressing today. Yeah. Is your finger ready? Excellent. Right, go. So today we're going to have a look at the galaxy in Starship Simulator. We'll have a quick look at why we're making a galaxy. We'll have a look at the anatomy of the Milky Way, some of the challenges that we faced in making the galaxy, some of the solutions we came up with, how we're developing life across the galaxy. We'll have a look at a few of the things we want to implement in the future, and then I'll take some questions, which I'm sure there are many. Next slide, please. So the first thing was why. I'm like, my God, why? Why am I doing this? And it comes down to a few factors. Next slide, please. So I put together a scale of openness. So on the far left there, you've got Star Citizen with its 2 star systems, and I believe they're going for 5 at launch, I think, at the last count. Obviously, yeah, no comment. Star systems are like heavily curated, very handcrafted. And you've got Starfield, which is a few more. Again, it's a mix of procedural and handcrafted. And you have Elite, the behemoth, with 400 billion star systems, a lot more on the procedural side. And then we've got No Man's Sky, which is just mental. Next slide, please. So this isn't perhaps entirely accurate, but I'm quite pleased with this. So I put together this Venn diagram to kind of sort of place where we are in the Star Sim community. So again, you've got No Man's Sky with its massive scale and just like crazy amounts of life and all over, like every planet's got something on it. You've got Elite with its scientific realism and a bit of life out there in the galaxy. And then you've got Space Engine, which is like fully scientifically realistic, massive scale, entire universe, and as far as I'm aware, no life. So we put ourselves like smack bang in the middle. So we want some of the scientific realism from Space Engine and Elite. We want the massive scale, and we want life across the whole galaxy, but not to the extent of No Man's Sky. We don't want life on everything. We want it to make sense and for it to be realistic. Next slide, please. So we know that we need to make the Milky Way. That's kind of where we want to go with the game. Next slide, please. So the Milky Way, and I'm sure most of you probably already know this, so apology if I'm teaching people how to suck eggs. But our galactic disk is 100,000 light years across. It's split into various regions. You've got the arm regions, the inter-arm regions, the bulge in the center. You have the thin disk region. I'm going to stand over here, maybe easier, wouldn't it? So you've got your thin disk right in the middle there. It's about 1,000 light years thick. You've got the thick disk that surrounds it. It goes about 10,000 light years thick. And then you've got the galactic halo around the outside, which is full of all your globular clusters, like tiny little mini galaxies. And then you've got, next slide, please, the extended features of the galaxy. And this really summarizes like the big picture of what we want to do. So you've got all the additional features, like you've got your stellar streams surrounding the halo. You've got your small and large Magellanic Clouds, just dwarf galaxies that orbit our galaxy. And again, this is kind of the final vision of what we want for the game. So we won't be going any further than this. This is the extent of what we want to do. But we really want to use like the dwarf galaxies for our end game content. They're far away. They're hard to get to, and that's where we want to put the juiciest stuff. Next slide, please. So the first challenge, and I think Douglas Adams sums it up perfectly here. I won't read that out because I will butcher it. But space is huge. And I didn't appreciate just how huge space is until I tried building it. It's crazy. It's just mind-bogglingly huge. I wanted the next star system to be about a minute away when calculating how fast to move the ship. Because I figured, well, if 60 seconds to the next bit of content seems about reasonable. But we have to move the ship at 2.5 million times the speed of light to get to the next star system in 60 seconds. I mean, that's how slow the speed of light is. It's snail's pace. Next slide, please. So in order to break that up into a reasonable scale, we've split the entire galactic halo into little chunks. So we've got millions and millions of these 100 light-year cubic sectors, and each one of those sectors has its own unique seed in the world. And we have a vector-based seed system, so that the seed for each sector is driven by that vector. I'm sorry, this is going to get techie and mathy at times. Apologies if it bores people. And then each one of those sectors is split into a further million subsectors. So you've got 100 light years by 100 light years by 100 light years, which equals a million, and those are the individual like star systems and bits of content within that sector. We're using 64-bit world coordinates for moving the ship around, which still isn't enough, but it's better than nothing. We still have some floating point errors in that, but we're coming up with some more solutions to help make that easier. I wrote an origin rebasing system to make life a little bit easier when moving the ship around, which I'll show in a sec. And ultimately, the player ship never gets further than 0.5 light years from the world origin. And that's important in a game engine, because your world origin is where everything's the most accurate. Your physics are the most accurate, your floating points are the most accurate, and the further you get from the world origin, the more the game engine just falls to pieces. So half a light year, even with 64-bit world coordinates, is still mental. You still get floating point errors. So again, we're working on solutions to kind of bring that down a bit. Next slide, please. So if you care to hit play, please. So this will be really quick to begin with, but this is basically the ship flying through the galaxy through all the different sectors. This is a scaled down version. And I think this was just a few million kilometers when I was testing. But essentially, when it reaches the edge of the cube, the ship is teleported to the opposing edge of that cube. So it feels like you're flying through the galaxy, but in fact, you're just teleporting to either side of this cube. And then, of course, we spawn the content within the center of that cube, which is the world origin. So the closer you get to a planet, the closer it's getting to the world origin. Do you want to just play that one more time? So again, so you have the illusion of flying through these cubes, when in fact you are literally just teleporting. As soon as you hit one edge, you teleport backwards to the opposing edge, and it gives you that illusion of continuous movement. And that's how we are able to fly the ship in real time across the whole galactic space. And then we use tricks like parallax and things for rendering giant structures like nebulae. So you'll have like a nebula in the galaxy, and it might actually only be a few hundred kilometers away from the ship and much smaller, but we move it so slowly that it gives the illusion of it being far away. And then we use a depth map within the game to make sure it always renders behind things, so it looks like it's far away. Next slide, please. Oh yeah, you have to like click next to it and then press spacebar. There we go. Sorry, I had that trouble as well. So we needed to come up with a coordinate system for our galaxy. And typically, coordinate systems will be sun-centric or Earth-centric, which I've never been a fan of, because that's kind of very, very human to kind of base everything all around where we are. So next slide, please. So instead, we split the galaxy up into Cartesian coordinates, with Sag right in the middle at 0, 0, 0, and then Sol at minus 26,500. That number varies depending on which paper you read, but it's accurate enough. We're 56 light years above the galactic plane. Generally, that's the consensus, and about 26,500 light years away. So every cubic light year within the galaxy has that particular coordinate system, and that's how we know where we are, that's how we know where the ship is and where the planets are, etc., etc. Next slide, please. So here you can see that in action. So you'll see that each star system listed there has its coordinates, and everything in the game is basically driven by those coordinates. Next slide. So in order to render the galactic shape, so we actually have a galaxy and not just a random mess of procedural stuff, We take this 1,000 by 1,000 pixel grayscale density map, and that represents the 100,000 light year diameter of the galaxy. So 100,000 light years divided into your 100 light year sectors, that's 1,000 sectors across. So each single pixel represents one sector of the galaxy. And then we do some math to calculate the vertical component of that. Obviously, in the center it's thicker, it's thinner around the outside. And things like the galactic halo are done purely by math. So we just use the grayscale image to do the density that drives the ongoing math from there. Each sector has between 0 and 8,000 stars. Right now, the cap is 8,000, because that's all the engine can handle. Anything more than that, then it really starts to chug and kill the CPU. I'll come into this a bit later, but we generate a 3 by 3 by 3 grid of sectors, and it's crazy how many sectors you get, even with that. That's 27 sectors that we're generating at once. And in the galactic core, where it caps at 8,000 stars per sector, that's 216,000 stars that we have to generate and sort and manipulate all at once, which is just a crazy number in an array. Next slide, please. So this is a closer look at the sector space itself. So again, each sector is 100 light years cubic, so that's 1 million subsectors. And a star system or a piece of content occupies one of those subsectors. This means we have a limit of half a light year for the radius of any particular star system. We cannot go beyond that. That's the limitation of the system that's been built. Now, it's very rare that a star system will be that big, so generally speaking, everything does fit. But in terms of us adding content to the galaxy, there are 1 million possible points of content per sector. Next slide, please. And that's what a sector looks like just within the game. So that is the 50 light year radius, so that's approximately how many stars you get per sector. And again, each one of those stars occupies a 1 light year cube, and the star system is located at the center of that cube. And next slide, please. So we are now generating alien civilizations across the galaxy. We do this by, on a per sector basis, we determine a political state for that sector. So a sector can have either just independent worlds. It can have a number of different factions with various relationships between them, or it can just have one giant empire that controls the whole sector. And we do that on a sector by sector basis. Each civilization has a tech level from 0 to 100, and that's generally defined by the age of their system. Humanity is tech level 20, to put it into the scale. Tech level 1 would be like primates, simple tool use. Crows actually are tech level 2 because they make and retain tools. So it's really, really cool when you look at different species and try and apply an arbitrary tech level to that. And obviously tech level 100 is going to be like godlike beings. We won't have anything quite that crazy in the game. Our most advanced civilizations can be likened to the sort of the ancients in Babylon 5, if you're a fan of that series, which I am. Yeah, big up Babylon 5. The FTL civilizations are generated in isolation. So when we first approached this, we wanted to have life in the galaxy driven 100% by the algorithm, so that they would just crop up, based on civilization developing around the conditions of their planet. And then we hit this problem where, because of the amount of generation you need to do, we couldn't generate a civilization until we knew that there was a planet there that they could live on. So we had this kind of chicken and egg problem. So in the end, we kind of had to bite the bullet and draw a line between FTL civilizations and non-FTL civilizations. So if they have FTL capability and they are flying around in space, obviously we want to be able to see their ships from outside of their homeworld. But we don't know that their homeworld exists until we've gone through the process of generating the star system. And if you think about 8,000 star systems in a sector, we can't do all of that all at once because it's a crazy amount of work. So what we do is we sprinkle FTL civilizations around a sector arbitrarily. So they're not generated from all the algorithms that do all the sciencey stuff for generating star systems. It's kind of one of those like game decisions you have to make sometimes. And I'm not completely happy with that, because I really wanted the whole thing to be like, Drake equation and solving it properly. But that's the limitation of what we're doing, so that's what we have to do. However, for non-FTL civilizations, we're doing the full Drake equation thing. So we first take the conditions of the planet, the age of the planet, and then we look at Earth as a baseline of how long life takes to develop and what kind of stages it goes through. And then those civilizations could be anything from like Stone Age civilizations up to industrial, but still not FTL. So you'll find those naturally throughout the galaxy, and you'll be able to help them and interact with them. They just won't have ships in space, and they don't get generated until you arrive at their star system. Next slide, please. Got to remember to breathe. So I don't know whether you can tell there because of the color, but there are some little green dots around, and those are the inhabited worlds. So this is a debug view that we have so that we can see where all the life exists within the galaxy. And in this particular sector, we've got 3 different empires, and you can see that you've got 3 clusters of inhabited worlds, and that's basically how that gets represented. So obviously, you don't see that when you're playing, but as you're out there exploring, you might come across one planet, figure out who these people are, and then if you make successful first contact, they might share the location of all their other planets, and then you'll start to build up a map of that civilization. Next slide, please. So, the Thanos problem. So, when you have a procedural galaxy and you change something, you change the entire galaxy. And this can be a big issue. And I've put a lot of safeguards in place to limit this issue as much as possible. Next slide, please. So when we're generating galactic sectors, we do so in isolation. So each sector is generated completely separately from the rest. They still inherit from the same code. They still rely on that density map to determine what type of sector they are, how many stars they have. So when you join them all together, you have that consistent galactic shape. But each sector is completely isolated from every other sector, which means that we can arbitrarily pull out one sector and manually craft everything within that sector rather than procedurally generating it. So as we add handcrafted civilizations down the line, we can do that without breaking the galaxy, which is a really important point. Each sector has its own seed pool, and again, that's driven by its coordinates. And each subsector also has its own seed pool. So for example, an O-class star will have a completely different seed and a completely different random stream from a B class, from a G class, from an F class, and so on. So the thing with random streams is every time you query that random stream to generate a random number, it processes that stream. So if we were to change something on, say, a G-class star, and we're accessing that random stream, all of a sudden, you could change something on an O-class star, because if they were sharing the same stream, everything affects each other. So we've separated that all out, so each class of star has its own random stream. So again, we're adding layers and layers of protection to the galaxy to allow us to make changes, to add things, to take things away, without breaking the rest of the galaxy. And obviously, the last point there, at some point, once we're done with the code, it will be locked down and that galaxy will be set in stone. And if we look at the little Thanos dude there, if he clicks his fingers in any of those sectors, it will only affect those individual sectors and not the rest of the galaxy. Next slide, please. So this is basically the steps we go through when generating the galactic space. It all gets kicked off when the ship moves. So when the coordinates of the ship changes, we run a check to see whether or not its sector has changed. And if the ship is in a new sector, then we recalculate that 3 by 3 by 3 array of 27 sectors. And then for each one, we read the pixel density, And at the moment, reading that from an image takes around about 20 to 30 milliseconds, which doesn't sound like a lot, but in game dev terms, that's a lifetime. And when you're doing it 27 times, that's a huge amount of delay. So we're doing all of this asynchronously in the background as much as we can. So it's not kind of lagging the engine. But we want to dump the text file, dump the image, and replace it with math at some point, and that gets rid of that 30 millisecond delay. We then assign all of our sector seeds. We determine whereabouts in the galaxy that sector is, so whether it's an arm region, an inter-arm region, whether it's part of the core, and that will drive a bunch of the other stuff further down the line. We determine the amount of stars within that sector. We determine our political state, so again, that's is it single empires, is it multiple empires, et cetera, We then retrieve all of our SQL data, so we've got our backer systems, our real-world stellar data, of which there's 18 million real-world stars now in the data. And we also have like a mod file now, so players can add their own star systems via just a SQLite database. We then do our procedural FTL civilizations, so again, we're just scattering those throughout the sector. We then generate all of our star systems and anything else. That could be anything from like a black hole to a rogue planet or anything like that. We just scatter them throughout the sector. We then generate all the text descriptions, and then we combine all of that into a single data pool, and that's anywhere from no star systems up to a cap of 216,000 star systems, again, which is crazy. We then filter that by distance, so things like M-class stars, we cap the limit on those around about 40 to 50 light years, because like 80% of the galaxy is M-class stars, and we can just get rid of 80% of the data really quickly if we cap them by distance, which just helps us manage everything. And we then sort that by distance to the ship, so we have our nice sorted list of stars. And that particular action happens every 1 light year as well. So we generate the whole thing about every 100 light years as you cross between sectors. And then we resort the list by order to the ship every time you cross into the next subsector, which is every 1 light year boundary. And eventually that's then just broadcast out to the game, to all the different game systems to say, right, here's all the stars around the ship, do with them what you want. Next slide, please. Okay, so this is the complicated one. So I've tried to simplify it as much as I can, but there's only so much you can fit on a slide. So everything in the game is driven by where the ship is. And that is great for adding things like wormholes, because all you have to do is move the ship and the whole game just updates accordingly. So we take our coordinates of the ship, and if there's a star system that's matching those coordinates, then we generate that data. Similarly, if you look it up on the sensors, that also generates that data. The first thing we do, we generate all the rest of the stuff we need for the star, because when we do the galactic stuff, we're generating a tiny, tiny bit of data for each star, basically the minimum we can get away with because there's so many of them. So when we generate the star system itself, which we're only doing one at a time, means we can go to town on generating the rest of that data. So that's things like the mass fractions of like hydrogen and helium, the escape velocity, the Roche limit of the star, basically all the rest of it, including its subclass, like is it an M class or is it an M2V, that sort of thing. We then generate the protoplanetary disk for the star system. Again, we do our mass fractions, so how much hydrogen, helium, and metals there are. We determine the lifespan of that protoplanetary disk depending on what type of star it is. Generally speaking, smaller, older stars like M-class have longer lasting protoplanetary disks. We generally use the star's Hill radius to define the outer limits of that disk and kind of bring it in over time. We then calculate our temperature regions. So that's everything from basically the dust sublimation line, which is where literally dust sublimates if it gets too close to the star, out to the Hill radius of that star. And then we calculate things like the habitable zone, the frost line, and we do that by taking an average Bond albedo, depending on whereabouts we're looking, and we use the equilibrium temperature. Sorry if this is like sciencey stuff, but we basically do all of that to generate those temperature zones. We then arbitrarily rotate the system because And it's one of those things that surprised me. It's like you kind of take it for granted that star systems are just like a flat plane, but every star system's rotated differently in the galaxy. Like they don't all line up with the galactic plane. So every star system's just randomly rotated. And then for each planet within that system, so we've got our mass pool for our protoplanetary disk. We determine the location of the innermost planet, and we just pick a random location between the dust sublimation line and a few AU. And we use something called a Titius-Bode law, or the black formulation of that. And there's a lot of debate in the scientific community about how valid that is as a scientific law. But basically, if you look at the planets in the solar system, most of them, there's a general increasing separation. So as you work your way outwards through the system, each planet is further and further away than the one before. And like the moons of Jupiter also use the same law in terms of their separation as you work outwards. It doesn't hold true all of the time, but we're using that as just a rough idea of where to roughly put each planet as we generate them, with some randomness to just make sure it doesn't fit the formula too closely. We then do core mass accretion. So we take our planetesimal and then we add mass to that planetesimal. The closer it is to the star, the more iron content it has. And then as you move outwards toward the system, it gets less and less iron as you go. We then determine whether it's a rocky planet or a gas giant. And we do that by basically, we take the thermal velocity of molecular hydrogen, and then we work out, is that more or less than the escape velocity of that planet? If it's less, then runaway gas accretion can occur, therefore it becomes a gas giant. If the planet cannot hold on to that, then it becomes a rocky planet. So you can see that they get generated slightly differently. So for gas giants, we do gas accretion. For rocky planets, we do things like the size of the core, the density of the core, the mantle, the crust, and we go through all that calculations. You'll be able to see that in game at some point, so you'll be able to have a cutaway diagram of each planet on the bridge, which will be quite cool. We then do all the physical characteristics. We look at the atmospheric composition, and then eventually, once we've done all of that work, we determine the final type of planet. So for gas giants, that's based on size and temperature. And then for rocky planets, that's based on some of the atmospheric stuff, and again, temperature. We then run our life gen code. And then finally, we deduct that mass from the protoplanetary disk and keep going until there's none left. And then the final thing we do is we generate a Kuiper belt. So every star system has a Kuiper belt equivalent, where we just scatter a number of icy bodies just around the outer system when we've run out of mass. Next slide, please. So this is kind of a list of wants that I have. Wormholes will be added very, very soon, so within the next couple of patches. They'll come in two flavors. You'll have stable wormholes, which have a set start and end point, and you can traverse back and forth through them at will. And then we'll have unstable wormholes, where once you enter them, the endpoint is going to be randomly generated and will not be there to come back. So good luck. And I think that's going to be quite a lot of fun, because you can have those like Voyager-style moments where you suddenly find yourself on the other side of the galaxy and you think, oh, crap. Regret going in that one. Rogue planets. To be honest, we've already got the ability to add rogue planets now, and the only reason I haven't is because they'll just be black balls in space with no lighting. So once we've got some way of highlighting rogue planets from the bridge, like doing an overlay of some kind, we'll add them in. Moons and multi-star systems, we don't have them yet, because we need to define the data structure for that. So on the back end right now, we generate a central star, and then we generate all the planets around it. To add multi-stars and moons and things, we need to greatly expand our data structure to support that. So that's one of the things that's coming soon. Protoplanetary disks, we want to add those that will be fully volumetric for the whole system. So you'll be able to go to systems that are still being created and see all those protoplanets being made. Volumetric planetary rings, that should be coming fairly soon. Fully volumetric gas giants, because one of the refueling metric for the game is going to be flying through gas giants. So skimming those upper cloud layers is how we'll be refueling the ship. So we want that to be fully volumetric, which should look epic. We can pull that off. Planetary nebulae, so basically supernovas. We want to add real-world nebula to the game. Right now, they're just procedural, so we want to make sure we get that properly modeled. So we've got actual real-world nebulas we can explore. Comets speak for themselves. Oort clouds. So basically, all that dust and debris and leftover matter forms like a shell around a star system, roughly equivalent to the Hill radius. And we want to render that in game with just like a really, really subtle, faint volumetric cloud, so that as you approach a star, you kind of pass through this like wispy sphere around the star. It has a kind of like a bell shape to it. So we're going to see if we can render those, which should look quite cool. Lots more stellar classes to come, so everything from neutron stars to magnetars and everything else. We're going to implement some more sci-fi based nebulas, so things that corrode the ship, things which mess with the sensors, that sort of thing. And then pretty much everything else we can think of. We have this galaxy, this massive playground where we can spawn stuff. So we just want to fill it with interesting things. And next slide, please. And I think that was pretty much it. Yeah. So, any questions? You're going to run around with the microphone?
Hello. Right, I'm going to run around. Do you want me to? Are you okay? Okay. Has anyone got any questions? Come on. Oh, right at the back there. Okay, so just in case you've never used one of these professional style mics before, it needs to be really close to your face, like that.
Yeah, like
they don't
how
work
I wasn't
at all like you think they do. Hello, sir.
Hi. So, have you given any thought to the hot Jupiters that have been observed currently, or is that something you're sort of still working on?
Yes, they are actually already in the game. So they are out there, and if you find them, they do actually glow. So if you go around to the dark side of those planets, you'll see a nice red glow from the back of them with the thermal radiation. So yeah, done.
Do you want me to get this up closer?
You keep to your side of the room.
Hi.
I know one of the things you talked about was like pre-written story content,
Yes.
Scripted missions and things. Do you have any plans, ideas, or stuff in the pipeline for that yet?
So we've got 3 expansions that are essentially going to be single-player campaigns. We have that penned out, and in a nutshell, the first expansion is going to be all about the exploration of the Milky Way, and you'll meet the big bad while you're exploring the galaxy. The second expansion is going to be about a war with that big bad, so it's going to be very combat-focused. And then the third expansion is going to be about rebuilding after that war. So there's going to be a lot of colony building. It's basically kind of inspired by Firefly a little bit. Yeah, big up Firefly.
Oh yeah.
Yeah. Yeah. So that's kind of the 3 stories that we have in the pipeline.
Anyone else?
What's your recommended PC spec?
Good question. So it keeps going up and up and up. So we're using Unreal Engine 5, and we're trying to turn on all the bells and whistles from Unreal Engine 5. Right now we have Nanite turned on, so we don't have to worry about poly count quite so much. We're not using Lumen yet, although we will be. So yeah, we're kind of, originally we had like a 1050 Ti as our baseline spec, and then we just blew through that completely. Something like a 3050 runs the game at about 60 FPS right now. So when it comes to defining like what is a reasonable spec, we're kind of looking at, what is the reasonable cost of a console? So like for a complete system for gaming, if that like console equivalent price can run the game at 60 frames a second, that's kind of where we're aiming at. But so I think a 3050 is about 150, 160 pounds right now. And it's the cost of a few AAA games. So we kind of think that's reasonable. I don't know. Opinions may vary.
We've probably got room for a couple more. Hang on, just run around. In. Oh dear God, I'm so tired.
Faster, Burr.
Thank you. Yeah.
Hi. I just want to ask about like persistence. For example, if you go to System X and find Planet Y, and there's certain things relate to that, if you were to jump out and come back, would you find the same thing?
Yes. So we have basically layered save files. So we've got scanning implemented now and saved, so you can explore star systems planet by planet, and it calculates what percentage of that system have you explored, and it now saves that. So if you come back, you can see that you've explored it X amount. When we implement dialogue with aliens and that sort of thing, their opinion towards you will be saved as well. So if you come back, say 6 months later, and to the same system, they will remember who you were, and they will have that same opinion towards you. So, if they've got beef with you, that won't have gone anywhere.
Okay, we're going to take one more, I think. Yeah. Anyone else? Excellent.
Like that? Lovely. Sorry. How exotic do you want to get with your exobiology, with your xenolife?
So we want to make sure that for every life that we add to the galaxy, or anything we add must have a scientific description behind it. So if we have like a gelatinous blob as an alien life form...
Right here, Dan.
Yeah, as exampled by Burr. We want to be able to have a scientific explanation about how that works. We want to be able to go into the biology of that creature and make sure that when you perform science on, say, a sample of that creature, what you see in game is like scientifically reasonable. So yes, we'll have beings of energy, yes, we'll have gelatinous blobs, but at the same time, we want to try and come up with some things scientifically plausible sounding for those species. We won't have anything like Q from Star Trek that can just click his fingers and change stuff. So we're not going like that advanced. Again, I think Babylon 5 is probably the best comparison I can draw for where we're going with our alien species. Yeah, plausible.
Brilliant stuff. Okay. Fleet Yard Studios, Dan and Claire Gouvier, and Starship Simulator, everybody. We're going to break now, aren't we?